Hello, everybody. Hello, Dr. Wang. First of all, thank you for this opportunity to be able to present this report for the presentation. Again, welcome to this presentation on the Lakehouse architecture for unifying data warehouse and advanced analytics. My name is Matthew Bolofinde. I'll be doing a summary presentation on the paper written by Ghodsi, Armbrust, Zaharia, and et al. On the topic of Lakehouse. Lakehouse, a new generation of open platform that unify data warehousing and advanced analytics. It's from a conference on innovative data system research, CIDR 2012. This will be an overview. This is a table of contents that gives an overview of the scope of this presentation. I will introduce the goal of this presentation, the key challenges addressed by this paper from Ghodsi et al. And then I will move on to the proposed solution architecture. Then finally, we look at the details of the architecture proposed, the solution proposed, and then I will look at the impact of the solution that has been proposed by Ghodsi et al. The Lakehouse architecture, by way of introduction, aims to unify the robust transactional capabilities and performance of data warehouses with the scalability and cost efficiencies of data lake. Now, by introducing transaction metadata layer, schema enforcement, and advanced indexing directly on cloud-based storage, the Lakehouse framework offers a single cohesive platform. This approach is geared to enable organizations to run their traditional business intelligence queries, real-time analytics, and advanced machine learning workload against a single authoritative data repository. This is to enable a simplified operation, reducing costs and accelerating decision-making cycle. Now, that is the focus of this paper that was written by Ghodsi et al. In introducing the Lakehouse architecture. The Lakehouse architecture combines the strength of data warehouse and data lake, providing a comprehensive and flexible platform and data storage processing and analytics. But before we get into the proposed solution, let us look at why did they come up with this? What was the problem they were trying to solve? We all know that data is the fundamental of everything that is done in terms of computing in business world and industry and in life general. And data warehouses were set up by companies as a way whereby they'll be able to generate insights. So data warehouses are critical for many businesses processing. But the traditional data warehouses in the past have always, been fraught with regular frustrated users who have to deal with sometimes incorrect data, staleness of data, and high cost of data. So the traditional data warehouse solutions, according to Ghodsi, argues that these challenges were accidental complexity, basically from the way enterprise data platforms were designed, which could be eliminated by what they're proposing in this paper called a Lakehouse. Now, the top problem reported by enterprise data users is usually data quality and reliability. And implementing correct data pipeline is even intrinsically difficult. But even with the architecture whereby you have your data sources and then you have your data warehouses referred to as a two-tier data architecture, which separates the data lake from the data warehouse. So in the data two-tier structure where we now have data lake where all the raw data are ingested from every of the data sources, either they are UI sources, relational data sources, web interfaces, and just flies like CSV file, and then that is where all the raw data are dumped, and then after some processing and transformation, the data are uploaded into this more structured, rigid data warehouses. But this process of the ETL, extract, transform, and load, introduced its own complexity that even exacerbated the problem. So business applications such as customer support systems and recommendation engines are, simply ineffective with stale data. And even human analysts querying warehouses report stale data as a major problem. And then you now have large fractions of data that is unstructured in many industries because organizations now have to collect images, sensor data, documents, and they require an easy-to-use system to manage this data. This was the challenge. And then be able to see even SQL-based data warehouse and API do not really support easily this unstructured data that they have to deal with. And again, we're looking at some of these challenges because now organizations are now deploying machine learning and data science application, but these are not well served by the traditional data warehouse or even the data lakes that are being designed as discussed before. But these applications need to process large amounts of data with non-SQL code which cannot run efficiently over the traditional ODBC and JDBC connectors. So as advanced analytics systems continue to develop, Ghodsi argued that they believe that by giving machine learning and data scientists direct access to data in the open format will be the best and open for them. In addition, machine learning and data science suffer from same data management issues, and such as data quality, consistency, and also in isolation. So there is immense value as proposed by Ghodsi et al. In bringing data management system features to the data implementation. So the proposed solution from the Ghodsi and et al. Was to implement what he referred to as the Lakehouse architecture, which is a combination of the data lake features and the data warehouse view. So by combining these best of these features of a data lake and data warehouse, they're able to provide a unified, scalable, and efficient platform for data storage, data processing, and data analytics. So they are introducing the transactional metadata layer. They are deploying an open columnar file format, and then they are bringing in the schema enforcement to manage ensuring data quality and consistencies across the data lake. And then they are introducing key performance optimization to support the entire architecture in the Lakehouse. So we're going to go into all these benefits because this is the proposition that was proposed then that has become a major household solution for organizations trying to see how they can derive more value from the amount and vast data that they currently gather. So the first thing they've introduced is we have what you call the transaction and version metadata, which follows the ACID compliance. So if you look at this here, you will see that in the ACID compliance that you find in most traditional relational database system, it talks about the atomicity, the consistency, the isolation, and durability. So the Lakehouse architecture, exemplified by a delta lake, which is the term that is used by the Databricks people that come up with this, it offers a robust solution for maintaining data quality and consistency by ACID transaction and version metadata. So this approach of making sure that this abstraction in the Lakehouse capability approach, enables this ACID compliance to be introduced as and associated, and then this brings a powerful combination and help organization to maintain the integrity and traceability of their data asset, enabling them to make informed decisions in the entire process. So you have atomicity that refers in terms of transactions. It's either all the transactions commit or nothing. So all the transactions are committed or nothing. And you talk about consistency of transactions, preserving the database invariant, making sure the state at one point, once the transactions are committed, is consistent at another state. Then you talk about isolation, making sure that all transactions are isolated from each other. So concurrent transactions are isolated from each other and there's no overlap. And then you talk about durability. Just in case of anything, once a transaction is committed, that transaction will stay there, and it's particularly when you're dealing with large-scale distributed data. In case of any failure on one node, once the data is committed, they should remain in that state. Then the next thing you talk about the columnar storage and performance enhancing. So the Lakehouse system leverage columnar format. Example, the most popular among them is the Parquet format. There's Avro and there's Orc as well. And these implement indexing, things, features, and data skipping and caching to minimize the input and output overhead, achieving a near warehouse performance even over cloud object store, because we're looking at how this has come into the cloud space. The next feature that we see in the Lakehouse is the open data format and interoperabilities. By maintaining an open file format and standard interface, the Lakehouse architecture avoid vendor lock-in and ensure compatibility with a broad ecosystem of tools, including SQL engines, BI platform, and machine learning framework. It also introduces a unified workload management for business intelligence and machine learning. So we are dealing with a single platform that supports transactional queues, batch processing, streaming ingestions, and advanced machine learning workload that allows teams to iterate rapidly and reduce ETLs overhead. That means extract ETLs and maintain consistent data governance across the different use case. So providing this unified, scalable, and efficient data platform, it empowers the analysts and data scientists to collaborate and drive business insight through a diverse workload. Now here we look at the conceptual architecture of the Lakehouse. So you can see the conceptual architecture of the Lakehouse, where you have all your data sources on one side, and then you have your batch or streaming configuration of the data pipeline. So you have your ingestion layer, then you have your storage layer, then you now have the metadata layer. So it can access whatever you have already in the data lake. So you have the ETL that is filling the data lake. So the data files are in open format of Parquet. And then you now have the metadata that is dealing with the transaction management and governance. So providing enhanced performance in terms of caching, indexing of the layer, and then you now have the intersection of the metadata APIs. So you have the SQL API, and you can also use the declarative data frame API, where it is now presented into the area of consumption. So now look at the next table. We'll now look at the comparative performance and features of the Lakehouse. So this table compares Lakehouse query latencies against traditional data warehouse. This is from the paper itself, demonstrating that from the experience and performance workload that were given to the system, it shows that Lakehouse designs approach warehouse performance while retaining the cost benefit of data lake. So you can see data warehouse, the latency is, is very low for data warehouse, and data lake, the query latency is high, but Lakehouse now introduces it from low to medium. So you can see transactional guarantee now available in Lakehouse, which is not available in data lakes. And then you can see the storage cost. So these are the trade-off. Your data warehouse is achieving a higher cost, while the Lakehouse brings the lower cost benefit. So you can see that by comparing the latency against traditional data warehouse and data, it shows that the Lakehouse design approach warehouse performance while also helping businesses to maximize cost. And then you can see things around the schema enforcement and governance comparison. So you can see for data warehouse, the data warehouse has the ACID transaction as yes, schema enforcement is very strict, and governance integrated, but it's limited in some of these features. Machine learning features are limited. Data lake has no ACID transactions. Schema enforcement is very flexible. Most times it is schema on read and not rigid like schema on write for data warehouse, and very limited. Machine learning is in data lake is easy but unstructured, while Lakehouse now brings in the ACID transaction, flexible and enforce schema enforcement, governance is integrated, and machine learning is also unified. The evaluation and impact of this that is demonstrated that its ability to deliver empirical results and drive industry-wide adoption. It has received enthusiastic user feedback, positioning it as a transformative technology in modern data management solution. And the results have shown that the Lakehouse presents that opportunity for more empirical data that have shown that data management from the empirical evaluation presented in the paper and from real-world deployments, like from example in Databricks Lakehouse platform, it has confirmed that organizations can achieve the robustness and performance of data warehouses while capitalizing on the scalability and low cost of data lakehouse. There are a lot of user testimonials and benchmarks that were referenced in the paper. It highlights reduced infrastructure complexity, improved time to insight, and streamline data engineering pipelines. And I want to thank you, Dr. Wang, for this, and this is my presentation in this. Thank you very much for your attention.